So we dig into this a little bit more. We can't just always go with the vertical line test. We do need to understand the definition that each input has only one output. Okay, so we look at these. Is this a function? I can either plot these if I really want to, but I don't. But I would like to be able to say, does each input have a specific output? Well, 1, 24, all these numbers are different, so there's nothing here that contradicts having its own output. So if I had another 1, if I needed to, or a 24, let's say, if 24 happened to be another input, I could predict that 25 would be the output because there's nothing that says otherwise. So I would say yes. Create an inverse table for the relation. You're basically just taking each of these and switching places. So instead of a 1, 2, it would be a 2, 1. If you input a 2 into the inverse function, out should come a 1 based on those. You see, switch all those. 25, 10, negative 2, and 0. 24, 9, negative 3, and negative 1. Same thing is true here. The inverse is a function, yes, because each x has only one y. Distinctly one y. And let me show you over here. And let me just do this here. Only one y. You might say, well, wait, there's another x value and it has another y value. Well, the other y value is the same y value as the input. So the fact that those are the same means that it is in fact a function. You look at this. Does it represent a function? Well, it's not a table or a graph, but I can still see input versus output. The answer is no to this one, specifically because negative 1 has 2 different outputs. Okay, that idea holds true. That's the best way to explain it. You can't really get away with saying because it passes the vertical line test. And so you do the same over here.